Okay, so for number one, you should have 8A plus 4H. You do not need to factor anything out there. After we go over this, I'm going to give you time to troubleshoot to see if you did something wrong, where you went wrong. And I was just going to let you know that when I was looking over it, if people got something wrong, it's generally when you're setting up this part. So you do have to FOIL, distribute that for, and somewhere in your work, you have to have this set up. So you have to have the f of 8 plus h minus f of a. I take that negative and distribute it, and I write it here so I don't have to write everything over again. And then once you get here, you can decide if you want to divide to get the final answer, or you can factor to get the final answer. Okay, and then for number two, it says find h of 10 and h of 66.3. When people are explaining, because we've done this in two sections with the inverse and without the inverse, sometimes people second guess themselves for how to write these. So if there's no inverse, the input is the horizontal distance. Okay, so this represents when the ball has traveled 10 feet horizontally. The height is 14.71. Okay, so what I did is I just highlighted for you what your input and your output were so that you could check those. Okay, and then for the second one, you could also say it represents the height of the soccer ball. The height of the soccer ball is 0.01 feet when the horizontal distance is 66.3. Okay, but you need to have in there the horizontal distance, and you need to have in there the height in feet. Okay, so what I'm looking for are these key terms, right? The height in feet, the horizontal distance, that's also measured in feet. Okay, and then it didn't say what to round to, so I rounded to the nearest hundredth. It's okay if you didn't. Okay, this is the decimal you got. So if you like rounded to 0.009, it didn't say, that's fine. Okay, your assessment will say what to round to, okay? Any questions for me about the explanations for those? So the higher the ball is, then the less distance it's going to travel horizontally. So this traveled far horizontally, which is why the height was so small. Okay, and then you guys had another story problem. Okay, and then your other story problem was about a small company that has a bunch of trucks. Okay, and it says that the maintenance cost, C in dollars, pardon? So the small delivery company noticed the cost of maintaining its trucks increases more quickly the further that they drive. Okay, and then where X is the number of thousands of miles driven. Okay, and so once you get these, you have to explain what these mean. So again, C's the cost in dollars, that's your output. Okay, here the input is going to be in thousands of miles. So when you see here, okay, that the output is the cost, we know that this is going to be 1,108, okay, in dollars, okay, and then this one is 8,101,000, and then that would be 200,000 miles. So whatever you have here If it's the input, because that's measured in thousands, you're going to take that 0.02 and you're going to multiply it by 1,000. Okay, so when you are doing the explanation, because it's measured in thousands, you are going to multiply by 1,000. Okay, and so this is talking about all the trucks for the company. Because if it was one truck, it would not make sense, right? That's a lot of money that it costs her. All right, and then when you're finding the domain for this function, you need a table. I'll show you my table, but I want us to understand when you need a table. So you need a table if you have a quadratic inequality. And you have an inequality for this one because it is underneath the radical. So you would take this value, you'd set it greater than or equal to 0, and that would be a quadratic inequality. Anytime you have a quadratic inequality, we're going to set up the table. Okay, so I'm just going to show you my table real quick. Okay, so what you would do is factor, find your two key values, then you can set up your intervals, find a test point in the intervals, and then because this is greater than or equal to 0, it's positive, and these are going to be hard brackets. Infinity will always have soft brackets. The two positive are going to be your solutions for this. All right, and then this is to make a table to support your graph. It is fine if you break this up into 3 tables like we did before, because I think that kind of confused some of you, right? You can also put it on one table. Like I just put my key values on one table there. Okay, like if you want to use your slope to find this, you could do that as well. I like to put where they're closed and where they're open. Okay, or you can do your 3 separate tables. So this one was for negative x minus 2. So this is going to be a closed circle at negative 1. This is from negative 1 to 2, so an open circle and an open circle. Okay, and then this is equal to 2, so that's going to be a closed circle. Okay, and so that is going to be your graph. How do we do on the piecewise? All right. All right, let's go to number 5. So when you are checking this, I just want you to know for 5A, because I've gotten a few questions about how you write that. This is when you say it's the y-coordinate at x equals. Okay, you know that from the directions because it says to find all the local maximum and minimum values and the value of x at which it occurs. So when you're finding the local max and min and the value of x at which it occurs, this is how you're going to write it. Okay, when you are finding the intervals on which the function is increasing and decreasing, you are going to use hard brackets there unless it's infinity. And it does say to state all answers correct to 2 decimal places. So with this one, with the 0, you guys had e to the negative 11th. So that would be 0.00000000000. Okay, so if you have 10 zeros, that is just going to round to 0. Okay, for the negative 2.00, did that show up as negative 1.99? Okay, so that's why I put the 2 zeros on that, because it is a rounded value. If it was just negative 2, you wouldn't have to put the 2 zeros there. Okay, so the minimums are 0 at x equals negative 2.00 and 0 at x equals 1.00. Your max is 5.06 at x equals negative 0.50. Okay, and again, those are rounded. This one just happened to have a lot of zeros in it. Okay, and then your increasing interval is negative infinity to negative 2.00, and then negative pi, and then 1.00 to infinity for your increasing, and then decreasing negative infinity to negative 2.00, okay, and then negative 0.50 to 1. So the only time you won't have a hard bracket is if it is infinity. The reason why I wrote this down, the x values, is sometimes that's a place where people get confused on the test. So feel free to write down a note. That way, if you're looking at your review as your way to study, that can be your reminder. Okay, and then let's check our answers for 6 if we haven't. So 6a is 3, and then b is 1/2 a plus 1/2. You can also write that as a plus 1 over 2. I had a few people do that. Okay, and then when you are finding the rate of change, that is the same thing as finding what? Yeah, you're just finding the slope, right? Okay, so do you guys have questions on 6a, part A? All right, let's talk about B because that one is kind of tricky. So if you know it's the slope, slope is a formula you've been using for a while. Okay, all we have to do is create a point. So if I know the input is 1, I'm just going to plug in 1. 1 squared is 1. 1 times a half is a half. A half plus 4, 4.5. When you plug in A, it's the exact same thing, except instead of x, you have A. So now I have my x1, y1, my x2, y2. I can just use my slope formula, 4 plus 1/2 a squared minus, and then 4.5. Now I made this my y2. It doesn't matter which one is your y2 and which one is your y1. But if you did switch this around, if you did a minus and it was a binomial, you have to remember to distribute. Okay, so just so you know. And then I have a minus 1 here. So if you do 4 minus 4.5, it's a half. That's negative. Or a minus 1. A half is your GCF, so you can factor that out. Okay, and then a squared minus 1 is the difference of 2 squares. Okay, so you can cross out the a minus 1s. Okay, so it's 1/2 times a plus 1, and then you can distribute. Did any of you leave it like this, the 1/2 a plus 1? Okay, because I would count that correct as well. Okay. And then again, if you did 1/2 times this and just put it over 2, that's okay as well. All right, other questions for me on that one? Okay, the next one is a calculator one. Make sure that you are labeling your units. It does say to round the answer to 2 decimal places, so it's 3.52 meters per second. Okay, so this is your input, this is your output. So again, you're finding your slope. Okay, and then for number 8, you should have 36, and then negative 3,130. Okay, and I know that one without a calculator was kind of large. I'm just going to show you what strategy I used. Okay, so when you do the step where you plug in 0, you have the negative 5, and then when you plug it back in, negative 5 to the 5th, I knew that if I did negative 5 to the 4th, I would get 625, because it's 25 times 25. So then I just did that times negative 5, okay, to get that value. And then when you subtract 5, it's the negative 3,130. All right, and then again, I'm just going to show you the solutions and then we're going to go over the work together. Okay, I know that 9 is difficult because there are a lot of solutions or a lot of concepts coming back around again. For your test, I decided to put on there that you don't have to rationalize, but you can. So I'll accept either one of these answers. Okay, so I'll accept this on the test or I'll accept this. Okay, and then this is your domain. The 1/2 has a bracket to 1 and then 1 to infinity. Okay, for G of F, again, you don't have to rationalize. Did any of you rationalize this? Okay, so people in my other classes didn't, but I did it out, so I can show you that as well. Okay, and then you do need a table for that. So the 2 cases where you need your table are going to be a quadratic and what type of function is this? What is that called? If you have an x in the denominator. If you have an x term in the denominator, what's it called? It starts with an R. No, it's underneath the rational. It's a rational. It's a rational function. Okay, so a rational function has that x in the denominator. Okay, if you did rationalize it, just so you know, this is what you'd have: the square root of -x squared plus 4x minus 3 over x minus 1. Did you say you did or you didn't? I thought it was that. Okay, that's all right. I didn't write it on there because I didn't want you guys to be confused. So don't worry if you did not do that. That's okay. Okay, so for f of f, you can either have x minus 1 over 2 minus x, or you can have x minus 1 over -x plus 2. Okay, and then sorry, I didn't read this domain, but hopefully you still checked it. And we're going to go over the table. I just want you to have your solutions written down, okay? So you have 1 to 3. This is a soft bracket. This is a hard bracket here. Okay, and then your domain. So I just double check because I know a lot of you got the 2, but we're going to talk about why you also need to exclude the 1. Okay, and then for G of G, you didn't have to simplify anything in G of G. So when you plugged it in, you can't simplify the root when you have this extra stuff underneath. Okay, and then that was 5/8 to infinity. Okay, so for f of G, okay, it doesn't matter which way you simplify your domain, you are still going to have 2 values to do this. Okay, so for f of G, if you're doing the domain for this one, here are the 2 things you would set up. 2x minus 1 is greater than or equal to 0. Just pay attention with me and then I will take questions, okay? So you have the 2x minus 1 is greater than or equal to 0 because that's underneath the root, and you also know that the denominator cannot be 0. So these are the 2 things you set up in order to find the domain for this. So you're going to get x is greater than or equal to 1/2. With this one, you would move it over, square both sides. 2x minus 1 would equal 1. Add it over, divide, and then you get x can't be 1. Okay, so when you set that up on a number line, okay, if it can't equal a value, you put an open circle there. If x is greater than 1/2, it includes all these values except the 1. And that's how you come up with this domain. Okay, if you were to simplify, then this value would be the same. You would set this up the same way, but then do you see how in the denominator, all you'd have to do is say 2x minus 2 doesn't equal 0? So 2x can't be 2, so x can't be 1. So you would solve this, which is a little bit simpler, but you would have to rationalize. So that's why I'm saying it's your choice of what you want to do, okay? So you can choose, those would be the two different methods. Questions on f of g? All right, let's talk g of g. First, do we need to go over how to simplify that so it's one term? Now we should talk about how to simplify that. Okay, yeah, no, it's fine. Just want to make sure I heard you. Okay, so when you are plugging this in for g of f, your first step, okay, is going to be 2x minus 1, and then you're plugging in that f of x there. When you plug that in, you are going to multiply, right, by the numerator, and then we have to get a common denominator, so we're going to multiply the top and the bottom by x minus 1. Everything we're doing under the radical is what we did in 1.4, in section 1.4, and so that stuff is coming back around. So when you distribute the negative, you have 2 minus x, and then don't forget, a negative times a negative is going to be a plus. Okay, so that is how you get 3 minus x in the numerator, or negative x plus 3, and then this is your denominator. Once you do that, when you're thinking about your domain, and you're setting this as greater than or equal to 0, what makes a rational function is you have an x term in the denominator. This is when you have to do your table. When you're doing your table, you have to find your key values. Okay, so what's going to be your key value that makes the numerator 0? What could I plug in for x that would make that 0 in the numerator? What would make the numerator 0? 3. What would make the denominator 0? 1. So this is the key, and if you want to look up how to do this, if you need a refresher, this is in 1.7. I believe we did this in day 1. Okay, so what we had to do is we had to keep in mind that you can't have this equal to 1. So it's negative infinity to 1 because x cannot be 1. It's in the denominator. 1 to 3, doesn't matter if it's 3 because that's in the top. Okay, and then we are going to make our chart. The two factors are 3 minus x and x minus 1. So if I plug in something in this interval, 0, 3 minus 0 is 3. 0 minus 1 is negative, so this is going to be a negative. If I plug in 2, 3 minus 2 is positive. 2 minus 1 is positive, so that one's going to be positive. 3 minus 4 is negative. 4 minus 1 is positive. Okay, so that's how this is our domain. Okay, we did our table. Okay, so you need that if you have a rational function underneath the denominator. Okay, so feel free to write that down as your reminder. And then for f of f, this is what I want to show you for the domain. Because I think we did a nice job of simplifying. This was your first step. Whenever you are plugging in a fraction, remember you have to exclude what would make this 0. So x can't be 1 in your first step, and then once you simplify it, you know this can't be equal to 0, so you have to exclude 2 as well. Okay, so if you guys only got the last one, just remember you have to check your first step as well. Okay, questions for me on that part? All right, then let's talk g of g. So when you do g of g, you have this big square root, and then you have a little square root, and you must find the domain for each of them. So when you find the domain for 2x minus 1, that's the radicand underneath this radical, you get x is greater than or equal to 1/2. But then this is the radicand underneath the larger radical. Okay, so you're going to add 1, divide by 2, square both sides. Okay, and then I added 1 to get 5/4. And then if you're dividing by 2 and it's a fraction, just multiply by 1/2. Okay, so x has to be greater than or equal to 1/2 and greater than or equal to 5/8. 5/8 is larger, so put it in the right spot. And then your domain is where they overlap. Okay, so they overlap starting at 5/8 to infinity. Okay, so that's going to be your domain value. All right, let's check our inverse. So there are 2 answers that you can have for your inverse. The first one is the most common. If you moved everything to the left side, if you moved it to the right, you would have got the second one. Again, you can write that as negative 3x plus 1. It's just you'll generally see it like that if the first value is negative. Okay, do we have questions on number 10? The inverse, feeling good about that? Moving them over to one side. This is where you have to factor. Okay? All right. The last one is another one where people tend to get confused. Okay? So when you're doing a test, it is helpful for you to highlight certain values. For A, how did finding the inverse go? The cube root of 5a minus 500. Okay, I need you guys to double check something. Make sure you have A. If you have X, you won't get full credit. Because if it's a story problem, what don't you do? Right, you don't switch around your variables. So this has to be an A here. Okay, so it's the cube root of 5a minus 500. Yeah, if you, do some of you not have 500, do you have negative 100? If people have negative 100, do we know what happens? You have to what? When you multiply by 5, what do you have to make sure you do? Distribute. Yep. Okay, and then when you plug in 300, okay, you are going to have to simplify. So notice this one's without a calculator, but when you plug it in, you just have to do the cube root of 1,000. And so you knew that was cat, right? Okay, so for the explanation, for the original, X is the amount of years and X is the input. If it's the input in the original, it's now going to be the output in the inverse, okay? So if it's X years is the input, now we know 10 years is the output, which means your input value, which you plug in for A, which again is helpful, A is measured in thousands of dollars. So I want you to check your explanation. If you said $300 after 10 years, you're missing a part of this. Because if it's in thousands of dollars, we have to multiply that by 1,000. Okay, so what does your answer in part B represent? My answer represents that after 10 years, the investment will be worth $300,000. Okay, I also saw some of you give a more detailed description, and that's great. So I had some people say that after 10 years, the investment that was compounded like 5% simple interest is worth $300,000. That is fine too. Okay, what I'll be looking for on this is the numbers and the units. So it's 10 years. Okay, it's $300,000. And you can put the dollar symbol or you can write dollars. I had people do both. All right, so what I want you to do now is if you got some of these wrong, I'm going to give you some time to troubleshoot and ask me questions and follow up.